Problem 5 for the halibut. So apparently there's a formula made by this very, very famous guy, the von Bertalanffy family. He came up with a formula that says that Pacific halibut grow according to a particular function, which is actually kind of a cool thing to know that there's a pretty regular growth pattern for these fish. So if you catch one, measure it, break out your little function here, and you can tell how old this fish is. So it says that the length in terms of time, years, is going to be given by 200 equals 1 minus this coefficient times e raised to a particular exponent. And LT is then the length in centimeters, and T is the age in years. So here we go. If you've ever caught a halibut, they are not a pretty fish. However, they do taste pretty good. So here we go. We're going to go to part A. And part A is going to ask, well, how big is a newborn? How big is a newborn halibut? Which is pretty crazy to when we figure out what the calculation is here. So a newborn is going to have a t-value of 0, right? So they're 0 years old, which is right now Isaac is a little over 0. He's a decimal, some little decimal. He's about 9 weeks old, 10 weeks old. But for all practical purposes, he's 0 in years. So if we want to calculate a newborn halibut, we got to give him a 0 for years. We're going to then plug in 0 into this function for the t's, and then we'll go about solving this, knowing that anything raised to the 0 power is going to then create a e to the 0 is then going to be 1, and e to the 1 times 0.0956 is then going to give us a nice little fraction here. And so I'm going to have 200 times 1 minus 0.0956. I'm going to take the 200 and distribute it through there, or just take 1 minus 0.0956. Either way you do that, you're going to end up doing this calculation here. And you'll have this little tiny baby halibut swimming and kicking around at 8.8 centimeters. Alright, tiny little fish. Now, if we want to convert that into inches, since we are Americans and we don't deal with the metric system very much, there's roughly 30 centimeters in 12 inches. So if you do a quick calculation, you get roughly 3.5 inches. So about the length of your, I don't know, maybe your middle finger or so. Tiny little halibut. So don't catch them. Don't eat them now. Too small. Alright, here we go. Part B says, alright, well, we want to know how fast these things are growing. So we're going to see how long this fish is. What's the length of this fish at 6 years old? So here we go. We're going to get our formula here again, and we're going to plug in a 6 for the t. So I end up with L of 6, that's a 6, not a B, equals 200 times 1 minus 0.956 e to the negative 0.18 times 6. Alright, so if I go ahead and start plugging and chugging those numbers, I get 200 times 1 minus now 0.956 times e to the 6 times negative 0.18 is negative 1.08, Now e to the negative 1.08 is 0.33959. I'm going to multiply that by 0.956, and I'm going to subtract that from 1, and then I'm going to multiply all that by 200. So again, this is going to be 1 minus something, which means it's going to be a number less than 200, and that number less than 200 is going to be 200 times 0.675, or 67%, which is going to give us 135 centimeters, roughly. Okay? And again, if there are 30 centimeters in a foot, 135 centimeters is roughly 4 times 30. So this is, in 6 years, this halibut's going to be over 4 feet long. Now, when I was a little kid, we went up to Deception Pass, and my dad caught a halibut and laid it down next to me, and the halibut was taller than I was. I was probably 7 years old, and this halibut was taller than I was when we were laying on the beach together. Pretty crazy. All right, part C is, all right, you've got a halibut. It's 120 centimeters long, so how old is it? Well, if we take that formula and we plug in 120 centimeters for the LT value and set that equal to our function, now I have one unknown, and it is the exponent, or the variable here, t, and so we'll go ahead and go about solving that thing. So the first thing that we're going to do is divide both sides by 200, and 120 divided by 200 is 0.6, and 0.6 is then going to be equal to 1 minus 0.956 e to the negative 0.18 t. Okay, well, you can kind of see where this is going. The parentheses at this point are not needed, and I'm going to do something just because I don't like dealing with negatives here. I'm going to take all of this stuff here, and I'm going to add it to the other side, and I'm going to take this thing right here, and I'm going to subtract it from both sides. So then I end up with an equation that has just positives on there. So I'm going to have 0.956 e equals 1 minus 0.6, or 0.4. If I then divide both sides by 0.956, I'm left with e to the negative 0.18 t equals, and 0.4 divided by 0.956 is 0.418. Now, next step will be to take the natural log of both sides, and then we will divide the natural log of 0.418 by a negative point. So at 120 centimeters, our halibut is almost 5 years old. Okay. What is the 200 in this? Since the x is, that means there's essentially the stuff in here is going to be a decreasing exponential. However, it's decreasing 1. If I take 0, so if I let the t is going to push me closer and closer times that 0.956 number, closer and closer to 1, or sorry, it's going to get me closer and closer to 0, and therefore I'm going to have 1. T goes to infinity, goes to 1. Essentially bigger than 200 centimeters. All right, yet here we go. Halibut are supposed to grow or age quite a long time. They don't die young, essentially. All right, so here we go. Here I've got my fisherman out there. This must be Skipper from Skipper's himself, and he says, "Hey, I just caught a 20-year-old fish." Followed right? So a t value of 20 calculated in terms of centimeters